Security is tough business. Trying to build and integrate all of those security elements to build out and strengthen your security posture is tough. And so we're going to go through a security overview focused on Cisco Security Integrated Architecture. This is going to be a whiteboard style presentation, and we're going to get right into it. We're going to break this up. We're going to build this out. I can't get into details of every single product because every product could take an hour plus, depending on needs, to walk through to give you a good overview. But I think I can give you enough insight into what Cisco provides from a security perspective that might be a little interesting. So let's check this out. So first thing, we've got this centralized malware sandbox. And so what this is going to allow us to do is look at malware, detonate malware from the outside looking in. So what does that mean? Well, that means that there's nothing in the virtual execution space that allows malware writers to determine whether or not they're being monitored. And there's things like fake documents and mouse movements, and you can interact with malware. There's all kinds of really neat stuff that you can do. The bottom line here is I'm centralizing my samples, and this is going to be key during any incident. I don't need to go to 10 or 20 different tools to try to figure out what happened. I want to keep that simple. Once we get a disposition, what we're going to do is update the AMP cloud with new information so this could be passed on to other security technologies within the stack and start mitigating against that risk. Then you've got email security. Well, like I mentioned, anything that needs to be sandboxed is going to be sent to that centralized sandbox and analyzed. And that's really good, right? Because I said earlier, we want to centralize that data. But email security is going to do things like outbreak filters, advanced malware inspection, phishing, gray mail, all of the stuff, block spam that you expect any email security appliance or solution, whether cloud or on-premise, to provide. And then we get into cloud security. Now, this includes things like first line of defense with DNS layer security, to web proxying, to anti-malware, to cloud access security broker. We've got application visibility and control with firewalling capabilities. We've got data loss prevention, intrusion prevention, and remote browser isolation. So we've got some really good capabilities that's going to allow us to follow the user regardless of where they go. If they're on-premise, there's some controls there. They look and feel and are managed the same. Same thing with a remote location that somebody's connected to, a branch office. Again, the controls are in the cloud, and work from home, right? Or at the local coffee shop, for example. We don't have to sacrifice some of the capabilities we expect on that asset. And then we've got domains themselves tied to samples. So the samples and domains themselves can be referenced within the platform and vice versa. So whether you're in malware analytics or in your cloud delivered security, you're going to be able to see that. And sandboxing as well is offered when you have something like web proxy in play. Then you get into traditional, which is odd, next generation firewalling. And that includes things like next gen IPS, advanced malware. You might have URL or content inspection there as well. You're going to do some decrypt in all of these, right? You can't get away without having decryption in place. So whether it's cloud delivered security or next gen firewall, there's going to be a requirement for decryption. But here's the thing, sandboxing. Again, if we see a sample on that next-gen firewall and it needs to be detonated in a sandbox environment, we're going to send it to that central location. Web proxy, traditional web proxy on-premise. It could even be delivered from the cloud. Sandboxing as well is going to be sent to that malware analytics engine. Then you got network-based identity and access control. We'll come back to that in a second. You've got flow analytics, looking at the network and the behavior of the network and any deviations. So if any of these controls fail, you have the opportunity to see something in the environment that may suggest bad and get alerted in the event something is happening. We'll come back to that a little bit more later. Then we got the endpoint itself, and you're going to have a certain level of control there as well, one of which will be endpoint protection. traditional, antivirus or anti-malware, mitigating controls. And then you're going to need something that allows you to determine what happens if a compromise or exposure happened. And that's going to be endpoint detection and response capabilities. Now, another key element is sandboxing. Anything that needs to be sandboxed can be sent to the centralized malware sandbox. And you can see what's happening here, whether it comes in email, web proxy, in the cloud, it comes from across a next-gen firewall or from the endpoint. It's all going to be centralized if sandboxing is required. You've got flow analytics here at the endpoint. So endpoint detection response does provide insight into the flows or connections, but they're typically bound by a certain number. So a process or an application may record up to 18, 25 flows, but not everything. That's where flow analytics comes on the endpoint, where you can capture everything and also stitch additional information in, like user device type, MAC, address, and process. Now, what's interesting here is that you will determine how you might go about your investigation just based on that information alone. So with flow analytics by itself, without enriching that data, you get 5 tuple, right? Source, destination IP, port, protocol. Now, if I can enrich it with this information that I'm showing here, now I can also see that it was Jason's laptop corporate device that Jason launched Firefox and went to something that was malicious, hopefully accidentally, versus maybe PowerShell launched under NT Authority's subsystem that went to a malicious IP address. Very, very different ways that you might go about handling that incident. Then you've got things like posture profiling 802.1x. That's where your network-based identity and access control system is going to come in. And so there's a tight tie-in here with understanding the assets and whether or not you want to allow them on the network based on a certain level of comfort. So I want it postured, I want it profiled, I want to know it's a Windows 10 corporate asset and not an IoT-based device that's trying to connect to a wired network, as an example. And any deviations from that over time, I may want to take action, meaning I might want to take a network-based approach to controlling whether or not that asset, like a camera that's now scanning the network, should continue to have access to the network. And then you add other things on the endpoint, right, that are going to be actually delivered from the cloud, but DNS security, web security, and proxy, and then you've got data loss prevention as well. Up in the far right, you might have seen cognitive come out. This is where we get into artificial intelligence and machine learning based on the flow data, proxy logs that we might be collecting. And this is really going to look for things that aren't easily found, that may have bypassed control. And so we've got flow data that could be sent to cognitive for supervised machine learning. You've got malware that also helps improve models within cognitive. You've got proxy logs that are supervised machine learning on that proxy log data. And you also have the ability to see this data and outcomes within secure endpoints. So you don't necessarily have to pivot. Now, some of the cool things here is that cognitive has obviously machine learning algorithms that they continue to mature, but also they once a human may have determined something, it's marked as what we call as confirmed. So confirmed just means that a human element has confirmed that these specific flows are something that you should take action against, versus detect, which may have been just the engines themselves that has determined that something suspicious might be happening, but we still need an analyst in your environment to determine that. And here's a screenshot of the capabilities around network analytics. So you can see things like recon, CNC, exploitation, data hoarding, any anomalies, and you can pivot into this and like really dig deep in regards to the flows and what might be happening in the environment. And this is just showcasing the cognitive details that you might get. And there's a ton more data here as well. But what you can do from here is that obviously see what risk level you might be at in certain areas, but you can see at the far right here, this ETA flag. And what that means is that encrypted traffic analytics, this flow is actually encrypted, and the ETA engine, or encrypted traffic analytics engine, actually determine that without having to decrypt the payload itself, right? Or being in the middle of that transaction and doing decrypt. It was able to take the flow data, run it through its engines, and determine that this flow, although encrypted, is suspect and obviously needs attention. And when you drill in a little bit, you get a little bit more details, right? Who the user is, the IP address, what security events might have happened. And you can see a couple of them here, right? Known to be indicative of Emotet, you got WannaCry, you've got some passive DNS information and some IP addressing. Here's an example of the malware analytics platform. So this is in the cloud. It can be on-premise as well, but driven mainly from the cloud. And what you're able to do here is not only see all your samples, but you can see samples that are being detonated. You can come in and interact with those samples. You can query this using an API, and then you can drill into a specific sample that you submitted, get the threat score, you know what operating system it was in and detonated, any of the behavioral indicators, registry entries, file entries. What's really cool though is up at the top here, this internal targets. So if I started here as an analyst looking for something based on a blog, for example, and I determined that, you know what, it is bad, it's actually going to reach out to the other systems in my environment and let me know whether or not we've seen this in the environment, and I'm going to flag it here. So for example, Secure Endpoint's going to tell me that 3 assets actually seen this specific sample, and now I know I've been potentially compromised, or a very strong indication of such. Then you got things like retrospection. So retrospection is you're not going to catch everything 100% of the time. And so things change based on the data you receive. And so maybe a sample gets into the environment, lands on an endpoint, which is never good. And later on, we determine something is bad. Maybe an hour, 2 hours, maybe a day, right? And what happens is that instead of just blocking everything net new, we actually tell you that this is a retrospective event and that you need to look to the left, right? What happened prior to us now blocking the file. And that's very important, right? Because you don't want to lose sight of things that may have come in over time that you didn't know about, and only start your analysis from when you determine something is bad moving forward or to the right. You have to go left and see whether or not you've been compromised. So we'll flag that SHA as an example as retrospective event. You need to look left. And here's an example on the next-gen firewall platform where there is a flag here that says retrospection. So pretty neat. As we move along, an analyst might determine something is bad. So again, based on the analyst's investigation, there might be evidence of a SHA that is suspect, and they want to block it. And they can do that right from the console. And when they do that and click that button, next-gen firewall, proxy, email security, etc., all become endpoints within Secure Endpoint. And the moment I block that, now I systemically block it everywhere. And that's pretty cool. And it's as simple as this. And this is showing you on the endpoint side. But if this SHA here was suspect, it is already marked as malicious, but let's assume it was green, and I went ahead and clicked it. All I have to do is add it to that simple detection, and that action's going to take place. I don't need to go into the firewall and email security and any of the other tools or third-party tools to make that happen. I can drive that outcome right from here. Threat containment. So now tying a lot of this together, so we've been sharing intelligence, but let's now start taking some action against some of the things that we might be seeing. So Secure Endpoint can also send sticks and taxi information to the network-based identity and access control system. And now I can use that information to take action. And I have a couple of options. One is I can just use secure endpoint to take host-based action, and I don't need any network-based control or feed intelligence to anything. So that's one option, and that allows me to take control and isolate maybe a machine anywhere it is. It could be at a coffee shop, it could be in the corporate environment, it could be remotely VPN'd in. It doesn't really matter. The other option is that sticks and the taxi data that is now shared with the network-based identity and access control system now has the ability to take action. So if it's say a catastrophic event, maybe I want to take a network-centric control against that asset, and I can do that. Again, we want to feed information into the next-gen firewall from the endpoint, because if we do see a bad file, we want to know whether or not, when we're in the actual management platform of the firewall, we want to know whether or not it's been quarantined on the endpoint. That's important, because if I have 500 files and 500 assets that pulled that file and 499 of them have been quarantined and that flag shows, it gives me a little sense of relief. Doesn't mean the game is over, but I know that at least that file has been quarantined. But more importantly, I want to know whether or not the user may have executed that. Now, again, I can always pivot to the endpoint product and view it there, but I was doing my research in the firewall. And so wouldn't it be nice to be able to have that information in the firewall? And in fact, we do. And same thing with applications that might be introducing IOCs. So you may have a non-sanctioned client application, maybe something like a browser that's non-sanctioned and users are using it. Well, now I have the ability to control or block that application from being used. Now, the firewall can also send information to the network-based identity and access control system and say, look, I've seen a behavior that's suspect here, and I want to take remediation action against that. So I'm letting you know that this is what I saw. You go ahead and take that network-based action against that asset. And again, this could be a printer that's compromised that's trying to, use FTP outbound as an example. Then you've got Flow Analytics Engine. We've talked a little bit about that with the supervised machine learning models and the proxy enhancements that feed into it to help with the intelligence that we're seeing or further enrich it. You've got device type, MAC, user, and process coming from the endpoint. The identity-based access control system on the network side can also share information to the analytics engine, again, stitching in user information, maybe applications and software. But the bottom line is that I have the ability to either automate some quarantine or unquarantining capability, for example, and manual as well. So for example, I might have within the Flow Analytics engine, if you see certain behaviors, take a certain action. Or I might be a user doing some analysis within the analytics engine, and I don't need to call out the networking team to say, look, I saw something of suspicion here. Can you guys go ahead and find out where it is on the network and shut down the port or remove it into a quarantine VLAN, whatever quarantine means to you. They have the ability to drive that outcome right from the platform that they're doing the investigation in. So then you get into secure workload. So this is now application or data center microsegmentation at the host level. And so you need to understand the applications that might be running on the asset. And so there's got to be some intelligence there to do that. And then obviously drive host-based controls based on that information. But we've got the ability to do threat containment not only at the host, but share information as we've been showing here. So we've got you've got endpoint data that could feed into secure workload, further enriching it. You've got network-based identity and access control that could further enrich the data that we're seeing, and it gives us visibility. And there's a much more integration than I'm showing here, but the slide would get way too busy. And then you've got automated enforcement. So for example, if I have an area of the network that doesn't have the workload agent installed on it for whatever reason, I have the ability to drive policy from secure workload and force or push that policy on the next gen firewall to take an L3, L4 centric based control approach versus an application layer or host based approach to securing that asset. But it still allows me to further extend my capabilities. And in fact, if you're securing at the endpoint, regardless, and you have to be 100% right all the time. So our ultimate goal is to move the protection mechanisms as far away from the asset as possible. Doesn't mean that we don't have them on the endpoint or on the server as an example, or workload. But we want to make sure that ideally we want to be blocking at the DNS layer, at the proxy layer, at the email layer, at the next network layer, right? Because then if we're wrong, we still have other layers to potentially catch it. Once it gets to the endpoint and something bad happens, it's game over. And here's an example of some of the policies that have been determined with the application intelligence that it has. And here you can see, some accesses between consumer or provider, so client or server, and then the actual ports and protocols that are required in order to allow that asset to continue to function. The biggest challenge within the data center is really understanding, what ports and protocols are required to allow an application or workload to fully function. And we've seen that in the industry when someone says, open up an L3, L4 control that's on the data center, right? Edge. Can you please open up these ports? And you do that, and they come back and say, well, wait a minute, it's still not working. And then you have to do a packet analysis and determine that they've got this other integration that they weren't aware of. And you know the drill, right? It's just tough business. This is going to tell us exactly what the application requires. Duo threat containment. So Duo provides, multi-factor authentication, device health. You got some conditional access capabilities. It's got a lot of really cool stuff. Lots of different applications it can support. There's no real limitations. But if, for example, you're in a remote location, connected to the internet, you open out Outlook, and just before that, before you actually log into Outlook, you go to a web page, you get compromised, and the endpoint product sees it enough to drive an alert or an outcome, or maybe the full compromise happens. And it may mitigate the risk. Hopefully it does, but you never know. There's some risk level there. And so you need an analyst to confirm whether or not that asset is still healthy or trustworthy. And so what you can do is integrate the endpoint with the MFA platform, Duo in this case. And if it sees that device as an indication of compromise driven with the integration between endpoint and Duo, don't allow that second factor to take place. So if I'm in Outlook and I put in my username and password and I've been compromised and they've got my username and password because there's a keylogger on it, I go into the second factor because endpoint saw it was bad. It's actually going to deny access into email or any sensitive or non-sensitive application that you want this layer of control on. That's pretty neat, right? Because that, again, is making sure that you're controlling or reducing your risk regardless of where that user is connecting from. And here's an example of that. There's just a quick integration with the API, and then I've got this checkbox that says allow Cisco Secure Endpoint to block compromised endpoints. That's it. We're off to the races. We've got additional control in the environment. And so when you think about this, though, and it falls in line very much with Zero Trust. And so there's three core elements within this slide that drive a Zero Trust outcome. Now, Zero Trust is a framework. It's not a product, but there's three core elements that are called out in this slide. All the other capabilities are complementary to driving towards Zero Trust and are required, but they are network-based identity and access control that helps drive Zero Trust from a network level. Before you connect to the network, we want to posture and assess. You've got Zero Trust in the data center and cloud for those workloads. So ensuring that those workloads only communicate at the host-based level to assets that they should be communicating, both the application and process tied to that communication channel. And then you've got the accessing the applications. So you've got Duo or multi-factor authentication. And again, I have the option to validate whether you've connected to the network. Now you're accessing a service. That's another connection event that takes place, and I have an opportunity to scrutinize whether or not I should allow you access, because you may have connected to the network and passed any of the validation a couple hours ago. And so you want to continually reevaluate throughout that process, but that helps drive towards zero trust. We've got the operational environment. So industrial security. So this is now where we start tying in and understanding what's in the operational environment, the patch levels of assets. You want to know vulnerabilities exist. You might want some anomaly detection, intrusion prevention, etc. But you can tie in this with your network-based identity access control system to do access control or micro-segmentation. You have the ability to pivot off and feed and understand what might be happening on the network from a flow, so analytics perspective. So that's now tying in IT and OT and bridging the gap between all of this. And then you may want to block upstream. So maybe you're using the Purdue model and you want to block at L3 or L3.5. You can drive that outcome further upstream to mitigate that risk. And here's an example of Cybervision. So this is showing you, the risk level of the environment. So you see 18 vulnerability or vulnerable devices. You got 55 devices with a risk score. And then it breaks down. You can start drilling into it. But you've got, deep packet inspection, dynamic asset inventory. You've got risk scoring. You can document your zones and conduits. You've got operational insights. This is the operational technology flight recorder, vulnerability detection, and it goes on. As we move along, now we got to look at the cloud environment. We've got Oracle, AWS, Google, Azure, and it goes on, right? But those are the core ones that exist. And so what you want to make sure is that these controls that you've built, whether they've been traditional on-premise or for the cloud, are the same across all these disparate systems. This is where life gets challenging as a practitioner, is that now I need to know the way Azure does things and AWS does things, and I've got my on-premise environment that does it this way, and how do I integrate all of these pieces? It gets very, very challenging. So you want to make sure that these capabilities can either be delivered in the cloud as well, or already delivered from the cloud. Multiple different technologies that we've covered can be driven from the cloud completely. When I said at the far right here, when I said cloud delivered security, this is kind of a bundled capability. It's not the only thing that we do in the cloud. Secure workload extends to the cloud. Endpoint extends to the cloud. Next gen firewall can be deployed in the cloud. Email security is delivered from the cloud. Malware analytics can be in the cloud. There's just lots of different options here on how you might want to leverage these capabilities. But as you're in the cloud, there are some specific things like cloud security analytics. So taking in flow data, understanding API calls and flagging them as they happen. So for example, you've got VPC logs that are in AWS. You've got NSG logs that are in Azure. You've got NetFlow logs that are in your on-premise environment. So, do you use multiple different tools to drive and understand what's happening, or do you centralize and come out with a cloud-based capability that can drive that outcome across all these disparate capabilities? And then you get into cyber asset attack surface management. And this now starts helping you identify where your weaknesses are in the cloud environment. It helps you meet in compliance. This is a step up from what you might have heard around cyber posture management platforms, or CSPMs. And so this is the evolution of that, the next generation maybe of that. And here's an example of that. You've got Cloud Insights here from Cisco, and you've got your frameworks, and it shows you where you sit in regards to meeting and complying with those frameworks. Obviously does a whole lot more than this, but that's just a sample. Risk-based vulnerability. So now you've got all this really cool stuff. Do you understand the vulnerabilities that might exist in the environment? And not only understanding the vulnerabilities, but understanding the risk level to your business. So I want to understand, yes, there is a vulnerability that exists, but am I really at risk for that? And so our risk-based vulnerability management platform takes that into consideration. And here's an example of this. This is giving me a nice score here at the top, and then it shows me CVEs and what the score level is based on my risk level. So you can see at the top here, it says top priority, active net breaches. You've got easily exploitable, predictable, malware exploitable, popular tags, etc. 0-day vulnerabilities. But this is the platform that helps drive towards a risk-based vulnerability solution or stack versus, what's traditionally been there, where you don't get enough insight into whether or not the asset's really at risk. And then you get into extended detection response. And you want to tie that into everything that you do, but you don't only leverage the Cisco stack or capabilities, but you also want to make sure that you're leveraging third party. You've got intelligence feeds coming in. You have identity and SIM and SOAR capabilities that might be over and above what you get with SecureX from Cisco. Now, this is going to help automate some of our responses. This is going to help us pull all of that information in as I'm hunting and trying to determine what's going on. And so we want to get into threat intelligence. So that's all powered by Talos, but we also have intelligence feeds. You got end-to-end telemetry signals, continuous trust assessment. So you don't want to trust anything at one point and that's it. You want to continually reevaluate it. And then you need automated orchestration capabilities. So you've got this nice architecture now starting to come together. And again, this is just a snippet of some of the potential capabilities. It's not everything. I don't have enough time. And then when you drill into the dashboarding, you can centralize all your products, not just Cisco technologies, but third party as well, and get that centralized dashboard that a lot of organizations have been striving to achieve. And this is an example of secure malware analytics engine that's very focused. And again, you would build this based on your needs. On the far right, you start getting into news information. On the far left, these are my modules that I can integrate with. Pretty neat. We also have the ability to provide threat hunting services that will also flag on that right side, as well as send you an email saying, look here, this is what's happened. Device insights. So this is new. Sorry for the screenshot. I don't have a great one here, but device insights. This is now going to tie into SecureX. And so you're going to pull data from Duo. You got examples of Mobile Iron or Microsoft Intune, etc. But this is going to help us understand what types of devices are connected to our network, what users have been accessing those devices, what are those devices located or where are they located, the vulnerabilities on the devices, which security agents are installed, is the security software up to date, and then what context do we have from technologies beyond the endpoint. So further enriching. Again, as you're threat hunting and looking for things in the environment, this is going to help put perspective and again, eliminate or limit your need to always jump to all these other different platforms to get the information you need. Here's the orchestration engine. This is an example of, for example, an event that might take place. And what's going to happen here is basically the event takes place. It's going to make sure that the data that was fed into the event itself has the right pieces we need to drive an outcome. So IP address, host name, AMP GUID as an example. And then what it's going to do is it's going to connect to endpoint AMP automatically. It's going to take an orbital query of that endpoint. So basically everything on the endpoint from a forensics perspective, it's going to capture processes, current logged in users, scheduled tasks, all that stuff. And then once that's complete, it's going to isolate the machine. And that's all going to be done automatically. And SecureX can get very, very interesting in regards to some of the playbooks and automation that you create. So for example, you get an email, I want to actually, and a user has said, look, this might be phishing. They click on it, it gets sent the alert gets sent here. And then from here, what it does is say, hey, oh, there's a link in here, or there's an attachment in here. There's an attachment. Let's run it in our malware analytics box and get the results. Open up a WebEx Teams room, add the security analyst to the Teams room itself so they can coordinate. And let's dump the information from the malware analytics engines on the outcome, and we'll isolate the machine. So it'll do that all automatically for the analyst or the responders. So they now are looking at the data. The risk is mitigated for now, and they can focus on driving the defensive capabilities that they need and truly understand what the risk was to the organization. Here's when you want to threat hunt. So you can do this from screen scraping using the browser plugin. You can do this by entering in information like a SHA or an IP address, etc. And you go ahead and hit investigate, and it gives you a relations graph and lets you understand what's happening. But what more important is I can take action from here now, which is really neat. And here's an example of an incident that's triggered. So you got your next gen firewall is feeding their incidents in here. You've got flow analytics that can feed incidents in here. And now my analysts don't need to go into the firewall to determine what might be happening. They have the events here and they can drill into this. So this isn't an incident. It's not assigned yet. I have the ability also to use the ribbon, which follows me around into different tools and platforms that I've integrated. And so I can very quickly parse information from the page. But I can also create an incident from that and really add the data I need, and then eventually create a case, which this might be part of. And so here's an example of the sightings of that incident. And you can see now I get in some details. I can see the relations and everything in here with an arrow down. For example, here and here and here, these are all drop down boxes that I can take action with. So pivot into another platform for additional insight. So again, this is just a small snippet of that. This is actually a casebook. So this has an incident tied to it, and or it doesn't, but it could have that incident that we saw tied to it. And then you've got your domains, that your observations that you might have added. You can see there's a couple here, and then you can drive or add some notes here based on timelines. And obviously this would be assigned to an individual, but anybody can look at it as well. And again, I can drop these arrows down, and here it's already showing me, just based on the icon, that this is malicious. And then down here, it's got an orange eye, just means suspicious. So keep an eye on these ones where you might have things that are showing up as gray or unknown. And then you've got this ribbon, again, as I mentioned, that follows you around, which is very, very handy. And as I go through, as I mentioned, I can click on this domain as an example. And when I do that, now I get a bunch of options that I could select. So I could jump right into Malware Analytics Engine and look for anything that went to retdemos.com. I can also use the orchestration engine and automate a response as an example. And there's a ton of things that you can add here. This is just, again, another sample. And that's it. That's all I got. Now, hopefully this gives you a little bit of insight into the overall capabilities of the Cisco Security platform. There's a lot of stuff, I know, but we only scratched the surface. But you can see how this integration is really coming together. You're never going to get away with a single vendor security approach. It's impossible. But you need to simplify where you can. And hopefully you saw some of that in this session.